In this video tutorial for Shape version 5, we are going to look at the draw particle tool that allows you to draw particles in positions such as these discrete filaments that we show in this object in the render module. This is a problem with the other conventional tools in Shape to place emission in very particular positions and directions. The draw particle tool will allow us to do this. It is located on the left side of the 3D module. We can select particle tab there, and there's our draw and erase tool. We're now going to place particles on this 3D mesh, which is a flattened spherical mesh. So we have a disk which has been oriented roughly to what we expect the disk to be in the object in the background. Now we are going to place the background image in our render view by going to the camera tab on the right and select for the background object observed. And now we can see our image in the background of the render module, which we are going to resize to its maximum extension. Now our object mesh, we're going to select the object mesh and make it slightly transparent so we can better see our background image. Therefore, we go to Primitive tab and increase the transparency setting to 0.8, 0.9, 0.8. So we can still see the mesh, but can have improved visibility for our background image. We now select our drawing tool on the left, and the cursor, the 3D cursor appears, whose motion is limited to the object that we have, mesh object that we have selected. We can drag the cursor around, and it is positioned on top of this mesh. If we now go to the tool tab on the right, we have the parameters for this tool. If we have selected our drawing tool on the left, we can now change the size of the cursor, which has a radius and a thickness setting. We can make it small now, so we can accommodate it to the size of our structures that we are going to draw. So we take down the radius to 1 × 10 to the 14 meters. And now we can start drawing on top of the mesh object by clicking and dragging. And there are several other parameters, like the number of parameters that we should set first to a smaller value, 10, which is the default. It will draw 10 particles per click or per time interval of stroke of dragging around the cursor. Now we click and drag. If we drag slowly, more particles will be applied to a certain area, and if we drag faster, then the number of particles will go down per unit volume. Depending on how we're going to render this, the number of particles means the brightness in the end, or they mean a sampling point in the volume. Now you can see that in two different positions we have two different colors, red and blue, which are associated with the red and blue shift on the object, and which helps us to identify structures that are on the front or back of an object, especially if it is a volume object, not like this disk, which is just flat. We will see this in a minute in more detail when we change the structure. Now you can go on and draw your filaments as needed. If you need lower density, then you can also change the number of particles that are drawn for every stroke or every click. And if you use physical renderer, you control the density with the density parameter in the tool. This is the density parameter that you need to change if you want higher density in the physical renderer. Or for the basic renderer, which we are going to use in this tutorial, you simply add more particles in the head position of these cometary knots, for example. If you drag faster, then the number of particles for the lower density regions is lower. Now we go and render this using our basic renderer. Select basic renderer and click on shape on rendering button. Now our transparency, changing the transparency of the background image, we can see that the rendered knots are right on top of our filaments as needed. The density of the particles can also be changed as usual using density modifiers as a function of that will apply density factors as a function of position. Note also that you need to change in order to erase particles, you can switch to the erase particles tool, which has its own 3D cursor, which is bigger by default, and you can then erase a large amount of particles in a very short time, or you can specify a smaller size to correct detailed structures on a particular filament. Depending on the pressure settings, either all particles in the volume of the cursor are deleted by setting it to 1, or some fraction by setting the value smaller than 1. We can also have an offset value for our cursor, which will then be placed at some distance from the 3D mesh, which is often useful if you have a different structure. Like now, let's have a look at re-establishing the spherical shape of this mesh to see this effect. Now our mesh is spherical, and as you can see at the edge, the cursor is actually on the surface. By drawing using the control button, you can either draw on the back or on the front side of the 3D mesh. Sometimes in the same position in a projected image you have filaments from the back and the front, so you can take into account both of these. As you can see at the edge, the cursor is now on the surface. If we add an offset value, we can change the positioning relative to the surface. Positive values will be outside, negative values will be inside of the sphere. So you're not completely restricted to the actual surface of the mesh object. If we now change the thickness parameter to a larger value, we can actually get a small stick-like cursor, which allows you to make filamentary structures that are perpendicular to the surface, such as those that occur in Rayleigh-Taylor instabilities and things like that. By positioning the cursor at some place and then clicking or dragging, you can make sheets of filaments. Let's have a look at this by rotating the camera view. Here you can see that it's a sheet that is actually sticking out and inside of the surface in a perpendicular to the surface mesh. And that's how it looks in the rendered view. There's our sheet-like filament. And that's it for our drawing tutorial. Oh, one more point to mention is that we can undo. It has an undo function where with every click you can remove a certain amount of particles, up to a total number that you can set. And in this case you can set a number which by default is 100 of the particles that is undone or deleted with every click on the undo button. It goes in reverse order of how the particles have been drawn. We should add that the density control of the particle drawing tool is effective only if in the 3D object modifiers you set the density modifier to its scale operation mode. So the density is taken from the particle itself, and then this density modifier only changes or rescales or adds density to the current setting from the particle itself. This is useful for detailed scaling as a function of distance or other parameters. And that's it for our 3D tutorial on the paint tool.